Welcome to the Linear Tigression show. This show is really based around kind of talking about data science topics and data analytics, kind of focusing more on that in how to use kind of Postgres and TimescaleDB to accomplish these awesome things. My name is Miranda All. I'm a developer advocate here at Timescale. Kind of slurring my words here for a little bit. Sorry. Okay,
dear.
David, you want to?
I'm David 𝗀𝗀. I am just starting off as the head of engineering education here at Timescale. So that's sort of internal and external education. I'm going to be doing a lot of stuff around Postgres, but other stuff as well. Still trying to figure out exactly what that means, but I've been a software developer here for almost 4 years. And yeah, so.
Yeah, we're super excited to have David switching to kind of like an educational role, because if you have not read his blog posts, they are excellent and you will learn a lot, I promise. So I'm going to go ahead and jump right on into today's topic, which is data cleaning techniques. So essentially, and if I look over here, it's because I apologize, I have to turn quite a bit to get access to my PowerPoint, so bear with me. So today I want to talk about data cleaning techniques. This is for kind of, folks who are doing data analysis, and particularly folks that maybe are not doing some of the quote unquote data munging parts of data analysis. And I count that as like evaluation, cleaning, and transformation of your data. Folks who aren't doing that in Postgres, and why you might want to start doing it in Postgres and TimescaleDB. And so that's kind of the topic of today, is how to kind of do your cleaning in Postgres, in your database directly, using TimescaleDB, and kind of the functionality that also just natively exists within Postgres. So what I would like to get through today, which is it's a hefty goal, but are all of these lovely points. First off, I would love to talk about the raw data that I'm going to be cleaning and just kind of describing why I really want to clean this data, why it's beneficial. We're going to talk about structural issues and how I could correct them within the database, creating or generating relevant data kind of off of existing columns, and then adding my data to a hypertable, which is a TimescaleDB specific object and functionality. And it's really great for kind of unlocking potential in time series data. Then we're going to discuss renaming values and then filling in missing data. So these are all the different techniques that I would like to go over, and just, topics. So first off, let's just quickly review the raw data that I'm going to use today. And so kind of starting off, this is the data that I got today is from Kaggle, and this great individual, here's the link to the data. This great individual shared energy data from their apartment in San Jose, I believe. And it's it's incrementing by 15 minutes. And it's showing the usage. We have like usage and units and all these kind of like fun things kind of from his energy readings. So that's super cool. Now, why I wanted to show you this structure is because there are some kind of initial issues that I saw when looking at this table. Like, it's awesome data, super great that this person shared this. But if you notice, date is a separate column from time, and cost is a text column. So these are kind of like initial things that kind of stood out to me, like, oh, I probably will want to clean this up in order to get the most out of my analysis. And just as like a snippet of what the raw data looks like, you can see we have like the type of data, the type of energy, the date, start time, end time, the usage, units, the type of units that is, the cost, and then notes. Okay.
So when you get this data from Kaggle, is it coming as like a CSV? What does it come as?
Yeah, so it comes as a CSV. Generally, that's how Kaggle does it. At least most of the data sets I've found are from CSV files. Yeah.
Okay.
Yeah.
And so the types are sort of inferred.
Yeah. So it's kind of, I'm sure that if you pull it into, other methods, you could probably do similar type of cleaning when you pull in the CSV to kind of reassign data types or anything like that. So, yeah. So, right, we have some, these issues that I talked about. How do we actually correct them in Postgres and TimescaleDB? So first off, why I want to correct the date and the start time kind of separate columns is because Timescale, right, it's a time series extension on Postgres. And so it uses, it's partitioning your tables by time. It's, it has all these kind of built-in functionality based around your time column, your time-based column. And to get the most functionality out of TimescaleDB, I want to use timestamp or, timestamp TZ rather than date and rather than just a date column. I mean, I could use just a date column, but having kind of the ability to have the granularity of the date and timestamp value will add a lot of value in the future. Like if I want to do maybe more granular continuous aggregates. I mean, David, you could probably speak to this a lot more, but there are just benefits to using timestamp rather than just date.
Yeah, I think that there are a few. I think it allows for easier indexing in general, and better conversions as well. You can always get either of the things back out if you want them, and run some very similar functions. So it's also tends to be more space efficient. I mean, there are some things that are a little bit more represented in terms of like the way that like you can represent, I think, a larger range of dates, but you'd really have to be going back way into the past if you really need a date that like is outside of the timestamp range. So it's one of those things where there's trade-offs, but in general, I tend to think that keeping it as one column is usually better form, and then extracting it out if you need to for various types of queries.
Awesome. Yeah, so we're then going to show kind of how to do that. How do I change this separate date time column into one timestamp column? How to change the data types. And then I actually want to put kind of this like first round of cleaning data into a view. And so I'll show SQL code for how to do all this good stuff. So the first thing that just kind of going off of what David was describing and how we index and partition data in our hypertables, which is like a specific, a timescale specific object. It's essentially like a normal table, right? It has all of your data. You could put like indexing on it yourself. And you could honestly put indexing like via time on it yourself, but we do that very easily for you by creating these hypertables. And so this image just kind of shows how we chunk your time-based data so that it queries more efficiently and stores like better. It's just a very cool tool when it comes to querying and kind of looking at data.
Yeah. So especially so a couple things just to note about why. Oh,
Sorry, that was my watch. Siri, for some reason, thought that I was talking to her.
Yeah. So when you're thinking about what a hypertable does, so it's a bit different than an index. That we do usually we create an index unless you turn that off. So we will create an index on time. But often you'll want other types of indexes as well. What the hypertable is doing is it's chunking the data even in the physical storage and in the heap, so where the data is stored on disk. And that means that the indexes can be smaller, and we can also exclude large portions of the table that aren't going to go into the heap. And this is, there are some databases that have like indexed organized tables, and you can think of it like kind of a little bit like that, but there's some other reasons why you might want to do that. And one of the reasons that hypertables do this is because there are also a lot of different types of operations that you perform on time series data, like archiving, like dropping certain portions, that really make sense along this time axis. And so chunking along the time axis tends to make a lot of sense. There are a lot of good reasons to do that. And it happens sort of automatically in the background as you're inserting new data. So it's somewhat useful for this type of sort of static analysis, but it's often even more useful as you get to applications where you're really ingesting data frequently. And that's going to be even more useful for you. So that's the sort of quick spiel on hypertables, if that's helpful.
Yeah, that's awesome. Thank you, David. So now let's jump to DBeaver and look at some code. Okay. So this is the raw table. So, and also I decided to pull in the raw data from the CSV file into a staging table and then kind of make adjustments there. So that's why I decided to name it energy usage staging, just so that I can clean up the data. And then once it's clean, then add it to a hypertable. And then maybe clean a little bit more, who knows? And then have that hypertable ready to kind of do analysis and really utilize timescale functionality to its best abilities. So this is the kind of starting off table. Oh, yes.
Do you want to tell them how you got the data in the first place?
Yeah, I mean, for this one, I just used, I think since this was a pretty small file, I think I just used the DBeaver importing tool for CSV files, just because it's not a ton of data. But
did you create the table first with the right columns, or like the column types and stuff?
Oh yeah, you have to create the table and then kind of map, how you want to do the have the CSV inserted into kind of these columns that you created. And so I just kind of followed what the default CSV file data types are and import that. And I can show
and you
you.
can also use things like copy to do this. And then there are other ways of doing things like that. One of the things actually that I heard a long time ago when I was at a different company, actually, and this is an interesting thing to do and think about. Like when I was looking at how I would analyze CSVs that I didn't really know the structure of to start with, I'd often import them first as just all text columns, and then figure out my cast from there. Like figure out what types, and that's sort of what we're going to do in some of this data cleaning, is like a lot of, a bit of sort of casting and other sorts of stuff. And that can be still reasonably efficient to do, and you can more programmatically create, say, a table from the column names, where you just say, okay, well, I'm not going to try and figure out what the type is in this column programmatically, because that would be hard, but I can just say everything's text to start, and then when I'm looking at it in my cleaning step, then I'll just do my tasks, and exactly sort of what we're going to go over here. So, yeah.
That's a great point. Yeah, maybe we'll have to include that in later streams or blog posts or something. Doing it all at once, which is nice. So kind of first off, how I can take this date column and which is right here, this date column and start time. So essentially, I decided to kind of ignore end time because it really doesn't add a lot of value, at least in my opinion, right? It's telling us that we're starting at 0, 0 for this row, going until the last minute of the 14th, minute, or the last second of the 14th minute. And then the next start time is, as soon as it ticks over to 15, right? It doesn't really,
it seems like it's wrong.
Yeah, it's not super
minute,
intuitive.
Right?
Yeah, I think it's like kind of, like bucketed to the end. So I kind of figured like this end time column is not, it's not doing anything for me. Like it's not really helping us at all. So I can just ignore that and just kind of add essentially, right? Because a timestamp, we have the date part of the timestamp and then the time part of a timestamp. And so what I can do with Postgres is literally just add. I literally just take the adding symbol and can make a timestamp column, which is really nice. That's just very simple, intuitive. You just add the two columns together, which I think is very nice. I think it makes, changing time values super easy, barely an inconvenience.
See how to get a better version of that that start and end time?
Oh, sorry, what was that? I didn't catch that.
Do you want to see how to get a better version of that end time?
Ooh, okay. Yeah.
So we know that these are 15-minute buckets, right?
I'll go back to this. Boom. Okay.
If you use the on that query that you just did, if you use the time bucket, the toolkit experimental time bucket range, you'll actually get a timestamp TZ range out.
Okay.
And then that'll actually give you the accurate start and end times.
This on a new line. Yeah. Oh, wait, I want to keep the as time there.
Probably need a space between the parens and as.
Oh, yeah, thank you. What was it? Range?
Time bucket range.
Time bucket range, like this?
Yep, and then it's the same inputs as time bucket. So in this case, it'll be, I guess, 15 minutes as an interval. And then you'll do the same date plus start time.
Okay. All right. Let's see if this works.
See if it works.
Oh, it does. Get something out of it.
The fun thing that you see there is, so you saw how that end time, they sort of subtracted a minute. When you do some of these things, like when you do end time, one of the things about range types in Postgres, and sorry, this is a complete digression. If you want me to stop, Miranda, and just
go for it. Please, it's fun.
But like one of the things about range types in Postgres that I like is that they incorporate this concept of inclusive and exclusive ranges. So you have a way of representing the fact that these ranges should be like right next to each other and sort of touching. That doesn't involve subtracting some unit of time from your time to do that. So if you subtract a unit of time, you end up with a gap, basically. Right. But if you don't, and if you say, okay, on the left side, it's inclusive, which means that the 0th minute in that first range is included, right? That's the start time. It's included. But then, and that's what the brace means, the square brace. But then on the right side, it's exclusive, which means that it goes up to, but doesn't include that value.
Using some math lingo here. It's like.
So ranges are really useful And range types can be really helpful for certain things. I think we're going to eventually actually move. The reason this one's still an experimental is actually because we're eventually going to move that over to the normal Timescale_DB extension, and let you use it more like time bucket itself, which would be really lovely. So
That'd be
I think
tight.
they're incredibly helpful. You can even build indexes around them. There's all sorts of fun stuff you can do. But yeah, so just thought I'd share that. Sorry
No, that's really cool. No. Interrupt all you want. That's super cool. Learn something new every day. So you could use, just the time, or if you want to include the range, you could use the Toolkit experimental time bucket range, which is fun. Yeah, that's really cool. I'm glad that you told me to throw that in there. Thanks. So then the next kind of issue that we saw, just kind of going back, I'm just going to put this in a different tab so we can jump around. Okay, sorry, need to stop breaking out into song and dance. It's a little too much for 2:30 on a Thursday. Clearly you can see I'm ready to take a break. So another issue that we had, right, is this cost column. It is a text value. That's at least how they import it. So one way that we can address the cost being a text value and kind of remapping it to a numeric value, which we can then analyze and actually maybe we want to do like a histogram of cost or something like that, and all that good stuff. Right, we have to change it back to a numeric. So one way we can do that is using a Postgres built-in function called toNumber, and it's pretty intuitive, right? Which is again awesome about SQL, is that it's very intuitive, which I really appreciate. Right, so toNumber casts the column to a number column. Cool. So when I run this, we're seeing kind of the original column and then this new numeric column that we can use. And essentially what I'm doing in this toNumber function right here, this first bit is essentially like telling Postgres which column I want to convert. And then this string is, I believe, and David, correct me if I'm wrong, which usually I am. So this kind of second bit is saying it is a Postgres kind of like mapping, like
I would call it a
string
format. Yeah, like format specifier.
Okay.
Something like
Format
that. Like it's
that's a good
telling
way of
it
describing it.
what format to expect the data in. I actually didn't know exactly how to do this, so I'm glad you found it. I hadn't actually done this sort of thing. So, but it seems, yeah, I mean, it's basically a formatting string as I understand it.
Yeah, and Postgres has in its documentation, it tells you kind of like what letters you can use to convert specific types of objects. So in this case, right, our string starts off with a number sign. I did like 3 things. Now we're playing charades. Who knew? So it starts off with a dollar sign. Why did I say number sign? A dollar sign. And then we have like a numeric value. And it's, in this case, what we see, at least in the first part, is that it's this like 0.65 kind of setup. So we have a decimal point that we're dealing with. And so how I decided to convert this string is this L kind of tells Postgres there's a special character starting off the string. So we want to, expect that there's going to be a special character. And then this like 9G999D99 is basically telling Postgres that there's going to be this numeric value after the special character. And so the 9, and I think you can also use 0 if you want. There's like specifications on the 9 and the 0, and what they do a little bit different things. But anyways, so the nines represent where there is a numeric value, and then this G represents a comma. So if say the cost, yeah, in the US, I should mention that, in the US, thank you. So if my cost goes up to, $1,000 or something, it's expected, like Postgres knows, okay, that comma in the 1,000 is still part of like the numeric values. So it knows to convert, that comma, like, oh, this is like one number altogether. This 1,000 is representing like 1,000 numerically. So the G is kind of like the comma, and then the D is the decimal point. So it's like two like numbers before the decimal point, three numbers, comma, up to like, 1,000 values. Anyways, so that's kind of like, I could have written it like, if all my cost data is less than, $9.99, I could just remove this, because, it's like one numeric value, then a decimal place, then two numeric values. I could do that. I mostly just added these extra like value spots to let Postgres know, just in case if I have really big cost values, it knows how to convert them, essentially. That was a long tangent, but anyways. So that's what this is doing. And this format string, kind of like how to use the format string. So cool. Now we have this timestamp value. I know how to make a timestamp from our date and start time. And I also know how to convert my cost. Sweet. So now I can kind of query or reselect, like query all my data with a new and improved schema, right?
So just a trick, by the way.
Mm-hmm.
I didn't know if this would work, but I just tested it and it does, if you want to play around with it. So instead of doing that whole thing with the format specifier and toNumber, Postgres does have a money type.
There you go.
And it is highly recommended that you never use the money type for pretty much anything, for all sorts of actually very good reasons, because it tends to truncate precision and all sorts of other stuff. So I don't recommend that you necessarily use it. But as a quick and dirty way of doing this, you could basically take cost, cast it to money, and then cast it to numeric, and it would work. So you can check that out and see if it does. I think I'm right, but I'm not 100% sure. Yeah, I think that should work for you. So just a thing to note, that like there are some things that will do that for you, and money is an interesting type. I would look into it. One of the other things just to note here is that I'm not sure exactly what would happen, but if you're not in the US or a place that uses $signs, it may not work. I'm not 100% sure, because it is locale based. You may need to set your locale to a US locale in order to use the money type that you're getting and actually have it parsed correctly. It's based on, locale is basically one of Postgres's ways to like say, this is where I am. So like, for instance, if you have a timestamp TZ and it appears at like your time zone, it's because the locale is set. But yeah, so I just wanted to note that as like a weird thing. So if someone's doing this somewhere in the rest of the world and they don't use $signs, something might go wonky if you're trying to use this data set. So you might have to set your locale first.
That's always some useful information. So locales, time zones, and like conversion things. It's a nightmare. It's a nightmare.
Yeah, it's truly a nightmare, but yeah.
So, right, this is the original table. We had those 3 columns for date and start time, and cost was a text. And now we have just the type, the timestamp, usage, units, cost is now a numeric column, and next and notes. But it looks empty, so we'll see what we have to do there. And then I just included this in case I had a view already made. But then once I have the data kind of set up in this like initial cleaning, I find it very useful to just throw it into a view so that I don't have to use CTE format and kind of like use that with as statement that we've talked about before, or you might be really familiar with it already. And this, again, it's really, this is just good for temporary, or at least, I don't know, I like it more for temporary kind of storage. It's not really storing anything. It just and if I were to call this view, which I do right here, right, it still has to run this select statement. So it's basically just like almost calling the select statement like by a variable so that I can call that instead of having to, reuse the select statement over and over again in my queries. So that's where views are really nice, is just kind of to keep your code from getting cluttered.
It also lets you share it with other people. That means you don't have to like share the actual select statement, but they can then select from that view. They can see the view definition as well, and it works just the same way. So then if you're working on a team and you're using a shared view, you're sort of getting the same thing, the same transformation between members of the team.
Yeah, great point. Filled with great points always, David. Love it. So next, kind of, I see this note column and I'm like, that looks pretty empty. And, is there even anything in it? So that's kind of like, this would be my next step in cleaning, is like, is there anything in it? So I use this where notes are not empty. So I'm essentially trying to query, are there any note values that are not empty? And the answer is no, all of them are empty. That's why I get nothing back with this query, because all the note values are empty. So kind of what I thought is like, well, all the notes are empty, but are there other column information that I could use to either later on, group my data by, that would be useful, or maybe like additional information that I could kind of grab from either dates that I have or whatever that could be useful. And one of those things I thought was day of the week, because maybe I want to group my data by, weekends versus weekdays, or maybe I want to look at one specific day of the week, like a Wednesday. And in the timestamp form, right, that's not super clear. But again, another great Postgres function that you can do to get the kind of cast the timestamp to a day of the week integer. And in Postgres, that's 0 to 6, right? One way that Postgres allows you to do this is by using this extract statement, and then DOW is day of week. Again, pretty intuitive. So I want to extract, and this, again, super cool about SQL and why I love it and why I really appreciate Postgres and TimescaleDB, which, why we built it the way that we did, is that it's very intuitive, right? I'm extracting the day of the week from my time column. Like, that just makes sense while reading. Like, it's pretty straightforward. And then this is just casting it to an integer value, the column that is, and renaming it as day of the week. So if I do this, and actually I'm going to make my other tab just the updated view now. So as you can see, the view that I created for our semi-cleaned data, right, it had the empty notes, had all this good stuff. And then when we add this day of the week, now we actually have an integer that kind of ties us to the day of the week. which I think is very useful. And, I could use an analysis later on. So that's kind of one thing that I could add. So then say that, okay, I have the day of the week, but what if I also want to know, I could, right, always in my queries say, like, figure out later on during analysis, I could extract, the day of the week or the weekend, but why not just set up my data, with all this information, like, ready to go to make my analysis as easy as possible. That's kind of like at least how I would probably work whenever I'm approaching data analysis. I don't want to take extra time to cast columns and stuff while I'm in analysis. It's nice to have just everything there ready to go. So another column that I might want to add is identifying is, the energy data that we're, showing in this row. Is it for, didn't mean to select a bunch of, is this row energy data that exists on a weekday or a weekend? Because I have the day of the week, but I don't have necessarily the identification of weekend versus weekday. So one way that I could add this new column is using a case statement. So these can be really useful. You can actually use this for renaming, and I'll show you that later as well. But I can do this case statement and say case when, my day of the week values are 0 or 6, with which for Postgres, this day of the week mapping, 0 and 6 are Saturday and Sunday. Then I want to identify the column as true. So I'm going to essentially create a binary column called is weekend.
Let's I think maybe it's more clear to call that a Boolean column. Binary sounds like code.
Yeah. No, good call. Okay. Good call. So a Boolean column, right? So true or false, 0 or 1, however best, you think about these things. I want to create this Boolean column where if it is the weekend, let the column be true. And if it's not the weekend, I want it to be false. And so I can use case when, we're value 0 or 6, then we set our column to true, and else we set it to false. And I'm renaming it as is weekend. And so if I run this, sorry, did you want to say
worries. So I don't know what that is. It's
kind of an interesting way of, if this is like another way, I'll show this version of it so you can see true.
Yeah, the thing that I like to do in these types of things, you don't actually need a case statement. You can.
Yeah, I'm actually this guy.
Mind. Look at this.
Already prepared. So case statements, they are very useful. But if you are just casting something to a Boolean setup, so it's true or false, there's actually a built-in Postgres way that makes this even easier. And so that's what David was talking about, is that I can just set up the statement. So replacing this case when statement with just kind of the argument inside here, and in. So basically this kind of says, like, extract the day of the week when that value is in 0 or 6, set it to true. So it kind of defaults as, when it is in, this certain set, we're going to default it to true. Otherwise, we're going to default it to false. So that's kind of what this line is saying, essentially.
So the nifty thing about this is, so the reason that at least some of this exists, right, is that, and if you think about it, right, that clause could go in your where clause, right? This is how Postgres evaluates things, right? For every row, it's saying, essentially, for a where clause, is this true or false? So a where, like anything that can go into a where clause reduces down to some sort of Boolean expression, right? It's either going to evaluate to true or false, and the row is either going to be a hit or a miss, right? So any of those operators you can use and then produce the Boolean expression. And then you can use that in your where clause if you want to. Like if you use it in a view, you could then use it in a where clause. But there are other ways that you could do it as well. I mean, and other reasons you might want to do that. But I just as a sort of peek behind the curtain of what's going on under the hood, this is exactly what's going on whenever you use a where clause. Like it's evaluating some Boolean expression. You can see the result of that then. So yeah.
And so you might also be asking, like, why create kind of a binary or Boolean column? I could say that to Boolean. And that's really what David is saying, is that if I can create these Boolean columns to kind of filter out specific questions that I might have, like if it is on a weekend, you know, maybe I want to look at the energy usage, you know, comparing like the weekend versus the weekday. I can literally, actually, I have some code down here, which I was going to show after. But so later on, I add another Boolean column, which kind of answers like, is it a holiday? If it is a holiday, it's going to be set true. If it's not a holiday, we set it to false. And what's nice is that with these Boolean columns, I can then filter by literally just calling where is weekend. So if I comment this out and I just want to select from my view where it's just the weekend, I can just use this statement. I think I actually didn't create this view yet because that's a little bit in a second. But if I add this here, I think it's because I haven't created
the view, and so you can't refer to the column that way, unfortunately, in the where clause.
Yeah.
I wish you could. It's one of my complaints with SQL, frankly.
It is a frustration. I'll just run this real quick because, you know, it runs anyways. So
yeah,
I'll set up. But yeah, I could call it and it.
So, and just as a sort of extension on that, if you don't want it to be weekend, then there are a few ways you could do that. You know how?
I actually don't.
Well, you can use not in front of it.
Oh, where? Not is weekend, that makes sense.
Exactly. So not is a keyword that just negates any sort of Boolean expression, right? And this is just a Boolean expression. So not will work. I think you can also do it with the exclamation point. So I think if you do
to be on it.
I think just the exclamation point, yeah, right next to it, and I think it should work.
Okay, let's try this. We're just experimenting here.
Yeah.
See, nope, that didn't like it. Okay, let's see. Space, maybe?
No.
No.
It might not work for that. Okay.
Not equal?
No.
Oh, okay. Well,
yeah,
not does work.
Yeah. Yeah, or you can say where is weekend equals false, right? Like that's, but I like where not is weekend, right? Like that, again, part of what I think we both like about SQL is that it reads reasonably well. It's relatively clear what you're trying to express. And so the sort of not is weekend, and that's part of why I like what you've done here, where you've named your Boolean variables is weekend or something like that. It makes it clear that it's a Boolean. right? And it reads nicely when I read that aloud. Where is weekend? Okay, I mean, obviously it's not quite grammatically correct, but you know, it's as good as most programming languages are in terms of following some semblance of the English language.
Yeah. So then just kind of to build off of this like Boolean information that maybe I could use, I decided also to add in holidays. And because coming from an analysis perspective, I likely will want, I could imagine that holidays could play into differences in energy usage. And so I decided to create a table that contains like all the different holidays. And so these are just federal holidays. And again, this is for the US because this individual lives in the US. This data is coming from, San Jose. So it's, they likely, this individual may have had some of these days off and maybe they have higher usage, or maybe I just want to look at, does holiday dates, like, does it play into any of their energy usage at their house? I don't know, but that's a question that I would want to ask. So I just created a table called holidays, inserted all these date values, and then now I can select from what's nice. Again, this is like a SQL thing. So I could join with the holidays table and kind of like pair up my timestamp data with the holidays that way. Or I can make my code more succinct and I can just throw this where, like, I can do time bucket, which is a timescale specific function. So I can apply time bucket to my timestamp, and then it will give me the date value for that day. And I can see where that date is in this holiday table. I want to create this new column that identifies as true, and otherwise will identify it as false if the date is not in the holiday set. And so if I were to not use time bucket here, it would only take the first, because it reads a single date value as like 2017, 12, 24, and then all zeros afterwards. So essentially this time bucket allows me to group all of the hourly data within my timestamp column and make sure that that is correctly being paired, with the holiday values.
Yeah,
so
and you can also just cast it to date is the other way to do it here. I mean, time bucket's really useful for especially things like that are not normal, like ways that you would truncate it. So yeah, but either way is fine here. So
yeah,
whichever you prefer.
And so if you can see, right, this code right here is just creating that this new holiday column, which is identifying as true or false. So then I just want to throw this like next step cleaned data into another view. So I'll just create this view, which I actually already did before. So if I select it, now I kind of have my second round of cleaning data. So I have, all the information that I want. I now have identification for if certain data falls on a weekend or on a holiday. So I can then use that in my analysis. And as we discussed before, now it's super easy to identify, where it's a holiday and a weekend. If I want to query just data that exists on a holiday and a weekend, I can do a select from my view and with just a simple where statement, which is really nice. I don't have to like do a bunch of code. I can literally just slap on where is weekend and is holiday, which is pretty cool, I think.
Yeah, and that's one of the things that I do like about some of these Boolean columns is it sometimes can make the logic a little more clear. Like when you're doing so like if I want to change this, okay, so this is where it's a weekend and a holiday. Well, if I want to do some Boolean logic, okay, well, we're not as weekend and it's a holiday. Okay, so these are all the holidays that don't fall on a weekend, right? That is maybe a useful thing. You could do where not, right? If I just want all the weekdays, like all the work days, right? That would be where not is weekend and or is holiday, and I need some parentheses in order to do that, right? Because I don't want it to be either a weekend or a holiday, right? So that's, that's where, so then you're going to get both of those are false, right? Like those are the types of things that now it allows me to do. Whereas if I have the like full statement in here, I find it to be a little bit more confusing potentially, right? So it can be nice to make these sorts of Boolean things to just make my logic a little more clear. So yeah.
Yeah. The last thing that I'll just show is adding data to a hypertable because that's really easy. And so I will hop back over to the code. There we go. This is the view I want. So, right, I have this extra generated columns. I cleaned up my data types, restructured my table. Then I got these 2 generated columns that I can use for kind of extra filtering. Now I'm pretty close to my fully cleaned data at this point, and so I actually want to put it into a TimescaleDB hypertable. And it's super easy to do that. And so I just thought I would go ahead and show you all how to do that. So I just create table energy usage. So now I'm not using, I don't have this staging table. I'm now have, I'm going to move it to a more permanent place. Now it's actually going to be stored in the database. So then I make sure that I have all the columns that I want to include, and that's all that exists in this expanded view that I just created. So we have, all the data plus the extra generated data. And to make it a hypertable, I just use select create hypertable, state the table name. So this is the, I ran this create table, which I've already done before, but I mean, it's going to error because I already have this table existing. But then, so I have the table name, and then the second bit of this create hypertable function. And right, again, this is a timescale specific function. So this is not a Postgres thing. This is a TimescaleDB thing. So this create hypertable takes in 2 or more arguments. There are other arguments that you can use, but the main arguments are the table name here, and then the time column on which to partition by. So this is the kind of the column that tells TimescaleDB how it's going to chunk your data, like that image that I showed earlier in the stream. So in this case, I want to use my timestamp column that we created here. So I would run this again, and since I already did it, it technically is erroring right now. And then to insert all of my awesome view data into this new table, I would use insert into the table name. Now that it's a hypertable, I can insert my data, and then I can just select all from my expanded view, and it will insert all of the data into it. And then I can select all from energy usage. So.
And you could imagine, and one of the things that I like about this is that you could imagine keeping that view around and then say truncating that other table and copying into that table when you got another set of data. So like maybe every day you get a new set of data, and then you run this sort of cleaning thing is that you insert into that, you copy it into that table, that's your sort of staging table, then you say select, and you just have a job that runs in the background. You could use one of our user-defined actions to do something like that, or you could use a cron job that did that. Like that's one of the sort of ETLing things that you could do with this type of approach. And I think that's an awesome way to do that.
Yeah. And so we made it through quite a bit of what I wanted to cover, actually, which is surprising because there were a lot of points. So maybe another time we'll cover kind of the last two topics that I was going to have us look at, which would have been renaming values and filling in missing data. And
wondering why it was so big.
Yeah. We're just spotlighting David.
Hey.
Probably I'll definitely do a stream on filling in missing data, because I think that can be really useful, especially if you're doing any kind of modeling, right? Missing data can really affect the accuracy of a model. And so I will make sure to show that next time. We'll look at the TimescaleDB gap filling methods, which are really cool. Yeah, so any questions for the two people that are on this stream? Please feel free to ask them if you have any. Yeah, thank you for joining us today. Hope that you all have a wonderful rest of your Thursday.
Yeah, and I think, are we, I don't think we're streaming next week. We haven't talked about this.
We are not going, we're actually going to be taking a break for the next 2 weeks. And that's because a lot of folks, actually including myself, will be gone for 2 weeks for the holidays. So we will not be meeting up the next 2 weeks.
If you really need a fix, all of these things are archived and you can find them.
Yes. Yeah. And actually this, if you're interested in kind of looking at more detail and getting some more information about what we discussed today, you can use this blog post. This is a link to the blog post that I wrote on all this, and it goes through, it's all the topics, and what I didn't cover as well is included in this blog post with examples and all that good stuff. So, and yeah, thank you, Claude, for watching. Thank you so much.
Yeah.
Glad to be here. Yeah. Have a great day. Have a great 2 weeks since we won't see you all. And enjoy the end of the year. And for people who are celebrating like holidays and stuff, have a good holidays. And see you next time.
Yeah, just one last thing, which is if you have questions, please you're welcome to put them on, like that you come up with when you're not watching this live. Feel free to put them in a comment. We'll try to answer them in either a future video or some other time. Or if you have other sorts of things that you want to go over, you can join our Slack channel or any of the other ways that we reach out to folks. So please do that. And we're happy to answer any more of your questions. And if there's things also that you want us to in particular cover in future shows, please do put those in comments. That's really helpful for us, just to know what people are looking for. If there are particular topics, if there's already something, we'll try to point you in the right place. But yeah, we would love if y'all have particular things that you want us to go over. We're really happy to take requests.
Yeah, please give us your feedback. If you want to see certain things or learn about certain topics, let us know, because we would love to cover them. Yes. Cool.
And if anyone is wondering why I'm bouncing, it's because I'm sitting on one of those medicine balls.
I was wondering. I didn't figure out myself. I was like, is his chair really bouncing? Or is he sitting on an exercise ball?
It also kind of sounds like I'm farting. I'm sorry if you thought that I was. I really am not. Yeah, so sorry about that.
And way too many beans for lunch,
yeah.
clearly. Well, my floorboards, every once in a while, I live in a very old home. My home was built 1890. It was 1890. And at least they think. They're not completely sure. But the floorboards are very creaky. So I often will, like, of course, now I can't find any creaky spots, of course. Oh, there, see?
Nice.
So I feel you, you know. We promise we're not gaseous. It's just, you know, random things in our homes. So. Or are we just lying?
Anyway,
all right.
Thanks, everyone.
Thanks, friends.
Have an awesome holidays if you celebrate, New Year and all of that. And see you next year.
Yes. Au revoir.
Bye.